All right, moving on with volume. Today we take a look at prisms and cylinders specifically. Prisms and cylinders. So we start off with kind of what we talked about yesterday in our last lesson regarding a cylinder and how you can have those slices. All right, those slices of a cylinder. And then just kind of roll them all out, right? Flatten them out. And that's what it would look like in 2D cross sections. They're basically circles. We said the area of the cross section was area is pi r squared in this case, okay, or whatever it is. In this case, how many cross sections are there? That's the height, and then it'll end up being pi r squared times the height. So that's the area formula for a cylinder that we're going to get right here. But really, we talked about any prism. You're just going to take the base area times the height. We talked about that in our last lesson. So this is all stuff that we should already know. All right, so let's get on to our examples here. In the accompanying diagram, the prism has a triangular base with a base edge of the triangle measuring 3 inches. The height of the triangular base is 4 inches, and the height of the prism is 10 inches. All right, so this is, and base doesn't necessarily mean bottom, because you could stand this up, right? You could stand it up the long way, and then the base, then the small triangle would be on the bottom. So in this case, they're calling the base the 3x4. So you could tell that this and this doesn't really matter. Call this 3, call this 4, or vice versa. And then the 10 is the height of the prism. So that could be this or this, right? They're all the same. This is a triangular prism. Why? Because the base is a triangle. All prisms have rectangles connecting the two bases, but you can see those bases are those triangle shapes. All right, so that's how we are identifying this prism here. All right, so how are we going to do it? We're going to do volume is base area times the height. All right, so now I'm going to do base area on the side. Base area is, for a triangle, it's 1/2 base times height, little b, h. Okay, so big B, I'm doing it on the side. 1/2 base times height, and that's talking about this triangle right here. See this triangle? This is the base of my prism. We're finding the area of this base, the area of that triangle. 3 times 4, very simple. And that's going to be 6. Okay, so half of 12 is 6, obviously. So that's this. So big B is 6. The area of the base is 6. That purple triangle has an area of 6. That means this triangle here also has an area of 6, because that's how a prism works. It's 2 congruent bases. Now the height of the prism is this 10 right here. That's the distance between the bases. So it's going to be times 10. That's the h. And then the total volume of my prism, the total volume, that's the space inside, is going to be 6 times 10, which should be 60. So again, to find the volume, it's going to be base area times height. A cylinder, again, is base area times height. You can do base area times height, but remember, B is pi r squared. When it's a cylinder, B is pi r squared. Capital B is pi r squared because the area of the base is pi r squared, since a circle is pi r squared. So I'll just plug that right in, and it becomes pi r squared h. And that's, so you could use either one of these formulas. If they already give you the base area already done, you're just going to plug that right in there. If they give you the radius, you're going to plug it into this one here. So you got to know both of those, and they're on your reference sheet for the Regents exam and for any quiz you take. All right, so I'm going to head over here and say, okay, so volume equals pi r squared h. All right, the diameter is 6. That means the radius is 3. The radius is half the diameter. You should know that. The height is 5. Height is 5. Diameter 6. All right, express in terms of pi. So it's going to be, this is 9 times 5, which is 45 pi. 45 pi. All right. Moving on, we're gonna take a look at, and that's just very basic volume. We're gonna look at a principle called Cavaliere's principle. Cavaliere's principle. Okay, in figure 1, all 3 rectangular prisms contain a cross-section with rectangles of equal areas. So see how we have 3 rectangular prisms here. You got this regular right, it's called a right rectangular prism, where it's nice, everything's nice, right? They make right angles and everything's perfect. But then they have this one here and this one here, where this one's kind of leaning over and this one's like all kinds of messed up, right? Kind of curved. It's a curved rectangular prism. These are called oblique. All right, they're not right, they're oblique. Oblique. All right, but the point is, based on Cavaliere's principle, it doesn't matter if it's oblique or right or curved or whatever, okay? As long as that cross section has the same area, that cross section has the same area as the base, okay? Same area as the base, talking about the two-dimensional base, and every cross section you can possibly make. So I could slice this forever, right? Slice, 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 slice. All these slices, we've done cross sections. All these slices, okay? Any slice you make and you do the area of that slice, that cross section, if all those areas are the same, are equal, then the solids will all have the same volume. If the area of the cross sections are all equal, it's got to be every cross section, then the volumes of those prisms will be the same. It doesn't matter if it's leaned over or not. Okay? So a nice example of that is this one here. So we have 2 trapezoidal prisms. See how the base is a trapezoid? 2 trapezoidal prisms are shown below. One is right and one is oblique. Both prisms have a height of 12.4. So the height is 12.4. Okay, the height is 12.4 for both of them. In both prisms, the area of every possible cross section is 36.7 square inches. So see, this is 36.7. This has area 36.7. This has area 36.7, 36.7. All of them are 36.7, and not just the ones drawn. Any cross section drawn. If I draw one here, okay, if I draw that cross section right there, and that trapezoid, that one has an area of 36.7. If I draw one here, that one has an area of 36.7. That's what every possible cross section means. Based on this information, what can you determine about the volumes of these prisms? Well, based on Cavaliere's principle, the volumes of these prisms will be equal because every cross section has the same area. Okay, so we're going to put that based on Cavaliere's principle. Based on Cavaliere's principle, these prisms will be equal in volume. Because every cross section has the same area. Okay? So if every cross section has the same area, you have equal volumes. Very, very simple principle. All right, our last example here, we're going to use Cavaliere's principle again to explain why a circular cylinder with a base of radius 5 and a height of 10 has the same volume as a square prism with edge length 5 radical pi and whose height is also 10. So I'm going to draw these out. I'm going to draw out to a cylinder here, all right, with a radius of 5, okay, and then a height of 10, and then a square prism. Just draw 2 squares and then just connect them. All right, where the base, we call this the base right here, has 5 radical pi it's 5 radical pi all the way around. That's because it's a square, right? So we got to find the area. If we're using Cavaliere's principle, you find the area of the base, So we'll do the area of the base for the cylinder. That's going to be pi r squared. So that's going to be pi times the radius, which was 5 squared. So that's going to be 25 pi. Now do the area of this base. Area of a square is side squared. Okay, you square the side. You square that, square this. So that's going to be 5 radical pi squared. So 5 squared is 25, and then when you square a radical, that cancels out, leaving just pi. So look what happens here. We did the area of the circular base. That came out to be 25 pi. We did the area of the square base, and that came out to be 25 pi. Based on Cavaliere's principle, as long as the heights are both 10, which it did say, the height of the prisms are both 10, prism or a cylinder, doesn't matter, then as long as the bases have the same area, then the volumes will be equal. Okay, so we're just going to say volumes equal because area of the bases are equal. All right, and that's good enough. I'll see you tomorrow.